Hi everyone, we're Group 5 and we're presenting our PAAR project, stands for Primary Age Asthma Reductions at City Heights Asthma Initiative. Our project goal is to increase asthma care knowledge and management among City Heights elementary students. We will be working with asthmatic and undiagnosed children having asthma symptoms aged 6 to 12 in 2 public schools.
Our study objectives is to enroll 60% of the identified asthmatic and at-risk school children in the intervention. Next, to reduce the number of school days missed due to asthma by 10% over the period of 1 school year. And lastly, by the end of the intervention, 70% of City Heights Elementary School students will score above a 6/10 on the asthma knowledge assessment. We are looking to answer the following questions. Is there a difference in asthma knowledge between the experimental group and comparison group? And what is the relationship between asthma knowledge and school attendance?
By campaigning at schools, we will obtain our sample population through a voluntary basis and non-probability, meaning it will not involve random selection, and we will identify all participants based on a parent response to our questionnaire. Our conceptual model is influenced by the social cognitive theory, and the constructs are knowledge towards asthma, asthma care management, which impacts the practice of learned asthma skills, and affected by the self-efficacy to manage symptoms, which leads to the missed school days due to asthma. Our design model for our project was a quasi-experimental design pre-test post-test, which is shown here. Our experimental group was the City Heights Elementary School, and our comparison group was the Rosa Parks Elementary School. For our research design, our experimental group received 60 asthma educational workshops, pre-test and post-test, and our comparison group received only the pre-test and post-test with no treatment.
To begin our evaluation, we identified the methods of data analysis that would best fit our program. Univariate analysis will look at demographics. Bivariate analysis will look at the asthma knowledge assessment surveys of the experimental and comparison groups, as well as school days missed due to asthma, and compare them for statistical significance, as well as multivariate, which would look at 3 or more variables. Running these analyses would be a good indicator of how our independent and dependent variables predict our alternative hypothesis. We decided to move forward with univariate and bivariate forms of analysis because they best fit our needs. Here you can see the race distribution of our participants is mostly of Hispanic background, which is consistent with the area of City Heights that we chose. And our other independent variable, age, the distribution is fairly even between 6 to 12-year-olds. We gave our participants a pre- and post-test survey in order to retrieve data on our independent variables, asthma knowledge, and missed school days. Here are some questions about asthma knowledge that we asked our participants to fill out. Part of our project goal was to increase the asthma management skills of our participants. So in order to assess this, we created questions that the school nurse helped to facilitate, and there was a rating scale of satisfactory or unsatisfactory, and the results of these questions helped to determine if our intervention did indeed impact the number of school days missed due to asthma.
For bivariate analysis, we conducted null hypothesis tests to observe the difference between the means of the dependent variables. Null hypothesis 1 is there is not an observed difference in asthma knowledge between the experimental and comparison groups. Null hypothesis 2 is there is not an observed difference in missed school days due to asthma between the experimental and comparison groups. Alternative hypotheses will reject the null 1 and 2. Independent t-tests were conducted to evaluate the post-mean scores of asthma knowledge in missed school days due to asthma among the experimental and comparison group. You can see the experimental group had a mean knowledge score of 9.3 out of 10, which is higher than the comparisons group knowledge mean of 7.3. The second t-test at the bottom shows that the experimental group had an average of 2.5 missed school days, which is lower than the comparison's mean days of 4 days. Our p-value was set at less than 0.05, meaning that we are 95% confident that our results were not by chance. We were interested in exploring why the intervention group had the increase in knowledge and decrease in missed school days, so we conducted dependent t-tests among the intervention group. Our objective 3 was, by the end of the intervention, 70% of City Heights Elementary School students will score above a 6 out of 10 on the asthma knowledge assessment, and our results show that 100% of the students scored above a 6 out of 10 on the test with a mean score of 9.1. Our objective 2 was to reduce the number of school days missed due to asthma by 10% over the period of 1 school year, and you can see that the pre-test mean was 4.1 days compared to post-test 2.5 days, which is a 39.1 reduction in school days missed. Based on these results, we reject the null hypothesis for both asthma knowledge and missed school days, as there is an observed difference between pre and post intervention. This graph easily illustrates the post-intervention results of the dependent t-test, inferring a relationship that with increased knowledge via our intervention, we observed a decrease in school days missed due to asthma.
Project limitations and advantages. No randomization affects the internal validity of the evaluation. Results cannot be generalized to the total survey population. There is selection bias. Some children grow out of having asthma. Separating results by grades would have made stronger findings. Using school records from previous years to compare missed school days. And the advantages are feasible with time, resources, and logistics. Comparison group allows for sufficient external validity and allows specific selection for our small targeted population with a pre-existing condition. This concludes our presentation. Thank you.